Okay, so the next section is going to talk about how to balance chemical reactions. So you always have to balance a chemical formula or a chemical reaction before you can use it. And you cannot do the following when you balance them. You can't change the identities of reactants and products, and you can't change the formulas of the compounds. So you can't change the subscripts, and you can't add or subtract atoms. So most equations can just be balanced by trial and error. So looking at what you have on each side and multiplying it by a number to get the same thing on the other side. So you always start with the most complicated molecule. So if we look in this equation here, we see that our most complicated molecule is this, the first reactant. So we will look at how many of each we have. So we have 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. So right now I'm just looking at this compound. So on the other side, we see that we have 1 carbon. So if we multiply CO2 times 2, we can get 2 carbons. So then those 2 will match. So now on this side, we have 2 carbons, 4 oxygens, 4 CO2, 2 hydrogens, and 1 oxygen for H2O. And then of course we have our 2 oxygens from O2 here. So our total oxygens on this side is only 3. So we can balance it by adding a coefficient in front of our water and our oxygen to balance the oxygens. So now we need to look at this. So we have 6 hydrogens on this side. So if we put a 3 in front of H2O, then that will give us 6 hydrogens. So now we have 6 hydrogens and 3 oxygens total, plus our 4 oxygens is 7. So that's 7 oxygens total. Then on our other side, we just have 3. So if we put a 3 in front of this, this will give us 6 oxygens from the O2, plus 1 oxygen here gives us 7 oxygens total. Okay, so that's taken care of. Our oxygens match, our carbons match. Now what about hydrogen? Hydrogens now match. So this equation is now balanced. And we can check that just by adding everything up again. So if we look at the new equation that we just made, we have 2 carbons on the left side, 6 hydrogens on the left side, 7 oxygens. Then on the right side, we have 2 carbons. 2 times 2 is 4, plus 3 oxygens is 7 oxygens. And 3 times 2 hydrogens is 6 hydrogens. So that's correct, and it is now balanced. So now we're going to look at another example from your textbook. This example is on page 108 if you want to take a look at it. So this problem tells us that 1000 degrees Celsius ammonia gas reacts with oxygen gas. So underline the things that you're given. So ammonia gas reacts with oxygen gas to form gaseous nitric oxide and water vapor. The reaction is the first step in the commercial production of nitric acid by the Ostwald process. It wants us to balance the equation for this reaction. Okay, so first thing, they gave us all the components of the reaction, but they didn't write it for us, right? So we need to look at what we're given. So it says ammonia gas reacts with oxygen gas to form nitric oxide and water vapor. So we are starting out with ammonia gas. They gave us the formula for that. It's NH3, and it's a gas, plus oxygen gas. Oxygen gas is always O2. And it forms, so that's an important word that tells you that these are the products. Nitric oxide, which is a gas, plus water vapor. So water is H2O, and it's a gas. Okay, so now all of these molecules in this equation are pretty simple, so we can start pretty much anywhere. It's kind of an arbitrary decision on where you should start. So if we look, we have one nitrogen, an NH3, and 3 hydrogens. Over here, we have one nitrogen, so that's good, but we only have 2 hydrogens contributing from the water. So in order to balance that, we're going to need 3 hydrogens here, so that gives us a total of 6. And then we can put a 2 in front of NH3 to give us 6 hydrogens there. So now we've balanced our hydrogens, but how has that changed the rest of our equation? So then we just need to check. So we have 2 nitrogens, 6 hydrogens, and 2 oxygens. Over here, we have 1 nitrogen, 4 oxygens, so that's 1 oxygen here, 3 here, and we have 6 hydrogens. So our hydrogens are good, so we can mark those out. So now we need to look at oxygen and nitrogen. So here we have 2 nitrogen, so we need 2 nitrogen over here. So if we put a 2 in front of the nitric oxide, then we get 2 nitrogen on the left side, and then our number of oxygens goes up to 5. Okay. So now we have everything balanced except our oxygens. So we have 2 oxygens here and 5 oxygens here. So one way you can do this is to balance it by saying you have 5 halves of O2. So it would be 2 times 2.5 basically. But we don't usually leave fractions in a balanced equation. So we're going to multiply everything by 2 in order to get rid of the 2 in the denominator. So now our balanced reaction is going to be 4 NH3 gas plus 5O2 gas yields 4NO gas plus 2 times 3 is 6 H2O gas. Okay, so now we can just check and make sure that is balanced. Scroll up some. Okay, so look at both sides in your total. So here we have 4 nitrogens. Here we have 4 nitrogens. We have 10 oxygens. Here we have 4 plus 6 oxygens, that's 10 oxygens. And then hydrogens, we have 3 times 4 is 12 hydrogens, and we have 6 times 2 is also 12 hydrogens. So check, this equation is balanced. So remember, when balancing them, look at both sides, see what you have and what is the easiest to balance first. Start with that and then work your way through trial and error, figuring out how to get equal numbers of all elements on both sides of the reaction. So products should have the same number of elements or atoms of elements, and reactants should have the same number. So keep that in mind, look at both sides and count your elements.